This is ChiCodeCrafty. Welcome to my channel. I want to talk to you guys about testing, software testing. So, software testing is actually the process of verifying that a software product actually does what it's supposed to do. Correct? There are several benefits of, software testing. So, I'm going to be dropping this article down somewhere down below so that you can just go through it to get more context. Okay. So for this testing, we're going to be using JUnit 5. So JUnit 5 is a testing library, for Java and JVMs. Okay. So yeah, let's jump right into it. So the first thing, we need to get the dependency for JUnit 5. So we go to the Maven repository, JUnit. That's it, the first one, right? So we're going to use the latest. We copy that. We go to our project. So at the pom.xml, we'll add it right here, dependencies, and we paste it. We can get rid of that. Boom, load it. Okay, so the next thing we want to do is right here in the test package, right? We create another package called com.ChiCodeCrafty. Okay, basically the same name as this. So right here, we'll add a class called calculator test. Okay, good. So that's it. So first things first, before we start testing, we actually want to know what the functionality of the calculator that class does before we start writing any test for it. Okay, as we can see, the calculator class has very basic method, very basic, about 4 methods in here: the add, the subtract, the multiply, and then the divide. Okay, so we are going to be testing each of these. So let's start with the add, and you can see the add just takes in 2 parameters and then returns the sum of both parameters. Quite easy. Okay, so right here we bring in the class private final calculator is equal to a new calculator. Okay, good. So next we create a method called add and then annotate this with test JUnit. So we can get rid of this. We're going to be using the AAA pattern, which stands for arrange, acts, and asserts. So this pattern actually makes our test readable, and easy to maintain. Yeah, I love using the AAA pattern. Really good pattern, to design your test. All right, so let's start with that. So we are starting with the add, takes in 2 parameters and then returns the sum of both of them. So for the arrange, we have our first parameter int a equal to 3. Let's give it value 3. Int b, let's give this a value, let's say 4. Okay, and then for the act, we have int result. This is the act, will be equal to calculator.add, and then we're passing a and passing b. And then for the assertions, we want to assert equals. We know 4 plus 3 is 7, so we are expecting our result to be 7, right? So we are asserting that 7 should be equal to our final result. Okay, good. So we can import that and then run the test. Awesome, you can see it passes. Awesome. So we do the same thing for the subtract method, basically almost the same, almost similar. Takes in 2 parameters and return the subtraction, of both values. So we have void subtract, okay, and same pattern, arrange, the act, and the asserts. So int A, our first value is going to be 5. Int B, our first value, let's say 3. And then for the results, is going to be our calculator that subtracts A from B. When you subtract A from B, then we assert equals, right? 5 subtracts 3, right? Then we are expecting 2. Our result should be 2, right? Good. We'll add the test at the top here. Awesome. Let's run this. Good. Passes as well. So we move to the next. Multiply. Pretty much the same thing. We have our void multiply. We annotate this with a test. Same pattern. Arrange, act, and assert. Int our first value should be 5. Int second value, let's say 5 or so. And our result should be, when we multiply both values, multiply A and B, then we should get 25. Then we assert equals 25 should be the result. Okay, and when we run this, good, passes as well, multiply. Now the divide, you can see it has one edge case which says if B is equal to 0, then we want to throw this exception right here. All right, otherwise we just return this. So let's do that. We have the void and divide. Happy path, right? Let's call this a happy path. Okay, just ignore my naming. My naming is really important, so we should really learn how to name things properly. So we're going to have arrange, same pattern, assert, act before assert, right? Good. So for this, the first value should be, let's say 5 as well. Int A, let's say 5. Int B, let's say 5 as well. And then the results, when you divide both values, A and B, then we should get 1. Then assert equals 1 should be the result. Let's run the test. Good. You can see passes. Now, if we want to test that our test is actually working, we can just pass in some negative values. If I pass in 2, then this should fail. That's it. You can see it fails. Expected 2, but the result is 1, right? So you can see our test works correctly. Okay. All right. So let's test for this edge case here where it says if B is equal to 0, then we are throwing this exception. If the second parameter is 0, then we are throwing the exception. So, okay. So we have void divide non-happy parts. Just ignore my naming, please. Non-happy path. Okay, so we add the tests. Good. Same pattern, arrange, acts, and the sats. Okay, int A, let's say 5. int b 0. So we are testing for the edge case. So here we're going to do things differently. So here we're throwing an exception. So we are expecting this exception right here. So we can assert throws that we are expecting this exception the class. We're expecting that exception the class when we call calculator dot divide a and b. Okay, let's break this down. Good. So we're expecting that this class throws an exception when we call this method with the second value b equals 0. We want it to throw an exception, right? So that's what we are asserting right there. And then we also want to assert equals the message in here cannot divide by 0. So we want to assert that. We want to assert that this message cannot divide by 0. So exception dot get message should equal that. So let's run this. You can see it passes. So let's actually see if our test is actually correct. So if I put zeros here, this should fail, right? Good. It fails. You can see it says cannot divide by zeros expected, but the actual is cannot divide by 0. As you can see here, cannot divide by 0. So that's it. Let's run everything together. Good. You can see all test passes. All right, guys. That's it. See you in the next. Bye.